Have you ever wondered how sound can move so effortlessly through walls? Or why you can hear a train coming long before it arrives if you press your ear to the track? It's almost like sound has a shortcut through solid objects. But here's the twist. It's not magic. It's physics. And it's about to blow your mind. Right now, you're probably surrounded by air, and we all know sound travels through it. But did you know that in steel, sound travels nearly 17 times faster than it does in the air you're breathing? Why is that? What's so special about solids that makes sound zip through them at incredible speeds? Stick around, because by the end of this video, not only will you understand the mind-blowing science behind this phenomenon, but you'll also see how this knowledge has shaped everything from earthquake detection to space exploration. And, spoiler alert, we'll even uncover a fascinating connection to the speed of light. Sound at its core is vibration. When something vibrates, it creates waves that travel through a medium, be it air, water, or solid steel. But here's the kicker. Not all materials let sound travel equally. Think about clapping your hands underwater versus above water. It's harder to hear underwater, right? Now imagine hitting two rocks together, but instead of being in the air, you're deep underground in a mine shaft. The sound would be sharper, louder, and reach your ears faster. Why? Because in solids, the molecules are packed much closer together. And that's just the beginning of what makes sound in solids so fascinating. Let's dig into the problem. Why does sound behave so differently in solids compared to air or liquids? And how has this simple yet powerful concept revolutionized the way we build bridges, explore the ocean floor, and even study the stars? Here's where things get interesting. We tend to take sound for granted. You hear someone talking, the hum of your fridge, or the whistle of the wind, and you don't think twice about how that sound gets to your ears. But let's throw a wrench in the works. Imagine you're in a submarine deep beneath the ocean's surface. You're trying to communicate with another submarine miles away. In water, sound moves about 4 times faster than in air, but even then, communication can be tricky. Now imagine sending that same signal through solid steel. The sound would arrive almost instantly compared to water. That speed difference is no small matter. It can be the difference between life and death in critical situations. The challenge isn't just about speed, it's also about understanding why this happens. Why can sound move faster in some materials but get bogged down in others? And here's another puzzle. If solids are so good at transmitting sound, why don't we always hear what's happening through walls, floors, or other solid objects around us? It's a paradox that only physics can explain. Sound is nothing more than vibrations that travel through a medium. When you clap your hands, the air around them compresses and decompresses, creating waves of pressure. These waves spread outward until they reach your ears. But here's the key. For sound to move, it needs something to travel through, a medium. Without a medium, there's no sound. That's why space is eerily silent. There's no air or other material to carry the vibrations. To understand why solids are faster, we need to zoom in on the atomic level. Imagine a row of people standing shoulder to shoulder, each one holding a spring connecting them to their neighbors. If you push the first person, the spring transfers the push to the next person, and so on. In a solid, atoms are like those tightly packed people. They're so close together that when one vibrates, it immediately passes the energy to its neighbors. In gases like air, the molecules are far apart, so it takes longer for the vibration to transfer from one to the next. Here's a concrete example. In air, sound travels at about 343 meters per second. In water, it's around 480 meters per second. But in steel, sound zips along at a whopping 5,960 meters per second. This massive difference is due to the density and arrangement of molecules in solids. But it's not just about density. Solids are also more elastic, meaning they can return to their original shape more easily after being deformed. This elasticity helps sound waves move through solids more efficiently. Take rubber and steel, for example. Rubber is dense, but it's not very elastic. Steel, on the other hand, is both dense and highly elastic, making it an ideal medium for sound waves. Sound travels faster in solids than in air, which has practical uses in various fields. For instance, train tracks transmit sound efficiently, allowing you to hear an approaching train through the steel before seeing it. In earthquake detection, seismologists study P waves and S waves, which reveal details about Earth's interior. Similarly, ultrasound technology applies sound wave principles to visualize internal organs, demonstrating the versatile role of sound propagation in solids and other media. Now, let's tackle one of the most mind-blowing connections, the relationship between sound and the speed of light. You might think light and sound are entirely different. After all, one is a wave of electromagnetic energy, and the other is a mechanical vibration. But they share a fascinating similarity. They both rely on the medium they travel through. For light, the medium can even be the vacuum of space, where it travels at its maximum speed, 186,000 miles per second. But just like sound, light slows down in denser materials. For instance, in glass, light slows to about 124,000 miles per second. Here's the kicker. Scientists have even slowed light down to 38 miles per hour in ultra-cold gases. This manipulation of light waves draws inspiration from how sound behaves in different materials. It's a direct example of how understanding sound in solids can influence breakthroughs in completely different fields. To sum it up, the speed of sound is a fascinating window into the physics of the world around us. From the tightly packed atoms in a solid to the elastic properties of materials like steel, the way sound moves tells us so much about the universe. Whether it's predicting earthquakes, improving communication technology, or even drawing parallels to the speed of light, understanding how sound travels in solids is more than just an academic exercise. It's a tool that shapes our everyday lives. And the next time you hear a faint sound through a wall or feel a vibration through the floor, you'll know there's a whole world of physics at play, moving faster than you ever imagined.